Hello, everyone, and first of all, thank you, organizers, for inviting me to give this talk, and I will speak about sound processing in smart home devices. I'm sure that not everyone here knows about Alango. We are not IBM, not Microsoft yet, so I will speak a little bit about our company. So we are a DSP software technologies company for voice, audio, and hearing enhancement. We have about 35 people. We're in Tirat Carmel here in Israel, and we also have a small R&D office in St. Petersburg, Russia. So we have representatives all over the world. And where's the, oops, no. Where's the pointer? Yeah. And we've been around for more than 15 years. We've given about more than 30 million product licenses so far, and it's growing fast. And our main areas are automotive, mobile and mobile accessories, conferencing, hearing enhancement, assistive listening, and today also pre-processing for automatic speech recognition. So we've seen in our, I've been in this area for more than 20 years, and I've seen several waves of interest in speech recognition. And the first wave that started in 52, obviously, I don't remember it. So, but starting from the late 90s, we've seen several waves of interest in dictation. And actually, in our field of speech enhancement for dictations, when it was considered like the bottleneck for the speech recognition, then we've seen this big splash with the introduction of Siri, when we had big, many requests for speech enhancement in mobile phones. Then came the area of the time of automotive. In 2012, after introducing Ford Sync, there was many requests for different companies and for speech enhancement in automotive. And these waves come and go. And in 2016, after introducing Amazon Echo, we've seen again a big wave of interest, and it's continuing for now. Many requests from different companies, semiconductor manufacturers, IP providers, speech recognition companies, product companies for these technologies. So these devices are considered today as by some people as the next big thing, and that's when they work, they really work very well. So many companies want now to copy these Amazon Echo devices, and you see this Google Home and Ding Dong. This is a Chinese company, which is the device is pretty good, and we have recently announced the HomePod device from Apple. So the user expectations actually are very, very high for these devices. These devices should be always on, listening, understanding, answering in all kinds of conditions. And the gold standard, of course, Amazon Echo, which works pretty well. So can it be done? Can these expectations be answered? We think that with one microphone is just like mission impossible. If we listen, if we have a device in the center of the living room with pretty high reverberation, and TV set working, and the device also producing some music, then the sound that the microphone will actually acquire will be something like this. Does it work?
But when it comes cloud outbreaks of rain and more in the way of windy weather, but it is temperatures generally stay above freezing.
So you heard the word Alexa in the middle, but any actually keyword recognition system will have troubles with such environment. So can we do something to alleviate, to remove, to make the life of speech recognition system easier? And that's where requests are coming to us, because everyone understands that speech recognition cannot work efficiently in such conditions, especially considering that we're in an embedded world. We don't have these GPUs and all this power. We are in a limited power, often battery-operated devices. So what we do, what we provide as a company, we provide technologies like beamforming, like echo cancellation, stereo echo cancellation, because our devices are stereo. So we have beamforming algorithms, some noise reduction, and actually the output of our technology goes to the speech recognition system. So that's what we provide as a company. This is our products. So if we listen again for the input, we'll just see what can be done with this input when we process them. So that will be again the input signal.
Right, but when it comes cloud outbreak spring and more in the way of windy weather, but at least temperatures generally stay above freezing.
So just by stereo echo cancellation, we will remove some part of the echo.
Friday, but when it comes cloud outbreak spring and more in the way of windy weather, but at least temperatures generally stay above freezing.
So it is much better, but probably not enough. And this will be something that already recognized by
Friday, but when it comes cloud outbreak spring and more in the way of windy weather, but at least temperatures generally stay above freezing.
It's a real recording in a reverberant living room with all these devices on. So does it really work? All this? How can this processing improve actually keyword recognition rate? And keyword recognition is the key technology or key factor for these devices, because as soon as you have the keyword recognized, you can mute the music that devices produce. Today, with the connected world, you can also even mute your TV set. So you can do a lot of things, but first you need to react on that. So what can we do for keyword recognition? Does it really work? Can we improve it? So we did multiple tests, again with the device and the test on the table in a real environment, with the mouse simulator producing the keyword, different distances, and some diffused noise produced by a loudspeaker that is turned to the wall to produce the diffused sound. So here are some results with the diffused noise. So this is the untreated 1 microphone signal. And we see that this is the voice level at the mouse reference points, which means 3 centimeters from the mouse simulator. And we see that the results drops very fast with the distance and also with the level of when the speech level is reduced. And we see that the pre-processing can significantly improve this result. So it's very consistent. We see that with the distance, the results becoming worse, but again they are consistently improving. Now this is what stereo echo cancellation can do also in these conditions. We see this is the untreated 1 microphone signal. The echo is obviously pretty high, so actually the keyword recognition doesn't work at all. Here we have 1 microphone case, and we see that the results were significantly improved. And with using the microphone array on top of the echo cancellation helps even more, and we see also that especially it helps with large distances, with distances like 2.5, 3 meters. We improve significantly the speech recognition results. And in our case, of course, in our case is this recognition by improvement by 3%. Yes.
Can you define what you mean by hit rate? Because you have both
Hit
false alarms.
Yes.
And
Well, first false alarms with good. We use sensory speech voice trigger, and the false alarms with it is really negligible. It's very, very robust. So it's a very good voice trigger, probably market leader today. So we almost don't have false positive. So we also only have negative results. And hit rate means from 100% how much is recognized. So it works. So what is the problem with that? The problem is that I don't know where I am. When we have a beamforming, it is actually pointing into some direction, but I don't know this direction. So I cannot, and all kind of steering, automatic steering will not work because the keyword is very, very short and we don't know where it comes from. So the solution that we propose, and that's what we call system approach, is to have the beamformer looking into different directions and producing multiple beams. And then actually this is just the example. Like this is the beam produced in the Talker direction.
When it becomes cloud over spring and more in the way of
Alexa.
weather, further east temperatures generally stay Friday, but
When we go off angle,
further east temperatures generally stay
we will see
Friday,
that.
but when it becomes cloud over spring and more in the way of windy weather, further east temperatures Friday, but when it comes cloud over spring and more in the way of windy weather, further east temperatures generally stay above freezing.
So we see that the beamforming allows us to enhance the sound coming from specific directions. So that's what we propose. We propose that we have the package that we actually licensing is called Voice Enhancement Package, and it has multiple inputs, which are inputs from microphones, stereo echo cancellation, and then beamforming producing multiple outputs to multiple directions. You can define the directions. And basically this is fed into the speech recognition system, which shall work something like this. So we have, this is our pre-processing block. Then we have multiple voice triggers. And actually the trigger that provides us with the best score is considered as the direction corresponding to the trigger recognized with the best score is considered as the main direction. It's possible also to utilize the power of because sometimes all triggers may provide relatively pretty similar result in the quiet conditions, for example. Then we may choose the beam with the maximum energy, for example. The triggers is better if they are synchronized, and this is already the work for keyword recognizer providers. These triggers, it's better when they are synchronized. So that means, because sometimes the triggers recognize the keyword at different times and produce different scores, and these scores are pretty meaningless. So this is the request, like say, request for the technology. We would like to have a block with multiple triggers that use all the inputs and provide like the information about the direction and the score, but they do the decision themselves. Then actually this is used as a switch for further speech recognition, which may be embedded command or network recognizer. We wanted to bring a demo here, but because the presentation is short, we wouldn't have time for that. So we decided to use some video recorded in our office, and I will show you this video now. Wait.
Hello, I'm Ruth.
And I'm Robert.
This is a demonstration of Alango's far-field speech enhancement algorithms and software.
The demo is a voice-controlled stereo music player with built-in 4-microphone array. The software integrates Alango proprietary voice enhancement package of software technologies, including stereo echo cancellation and far-field beamforming. The output signal from the voice enhancement package is fed into sensory speech recognition software which is used to interpret user commands. So let's go through some commands. The system wake-up phrase is, "Hello, Blue Genie." Hello, Blue Genie. Play music.
Stop this world. Let me off.
Hello, Blue Genie.
There's
Next song.
just no room.
Hello, Blue Genie. Stop music.
Now we're going to introduce some ambient noise and run through the commands again. Hello, Blue Genie. Play music.
Hello, Blue Genie. Next song. Hello, Blue Genie. Previous song.
Hello, Blue Genie. Next song. Hello, Blue Genie. Stop music.
Now some numbers. So because we're in the embedded world, we don't have a supercomputer to run it. So just some numbers about the complexity of the computations. We need to do this pre-processing. So it's defined actually. We have we are in the industry. We don't use complex formulas. So our formulas are very simple, and that allows us to compute the resources that we need. It's defined by the number of microphones, which is M, and the number of it should be N actually. At the first, it's my fault. I just made this presentation yesterday night, so it should be N, and this should be M. So N is the number of microphones, and M is the number of directions. So with 4 microphones, we can create like 8 directions, and that's what we need, about 256 megahertz, and this is the amount of memory we need on the embedded device. With 6 microphones, we can have 6 directions. Actually, this is the best. And these are the resources. And with the maximum configurations of 8 microphones and 8 directions, then these are the resources with about 400 megahertz on ARM. This is all relevant for Cortex, ARM Cortex A9, which is the industry standard today for this type of devices. And this is the end of my presentations, and please, questions. Thank you.
Considering you have both microphones and speakers, have you tried, do you think it would be a good idea to play specific sounds in order to try and model the room impulse response or other convolutive or additive effects on the audio?
Well, it is potentially possible, but for a consumer device, it will not be accepted. I mean, all rooms are different, so you cannot ask a user to put a device in a fixed place and then ask to do some kind of, learning the environment, because the device may be moved. The people around may move, and it will all change the impulse response very significantly. So it is possible in some environments, like cars, for example, where everything is more or less fixed. But in smart home devices, it will not be accepted by users.
I was wondering, following the demo that you have showed, what happens when the person starts walking around the room? I mean,
it's a good question. And here is, well, first, we assume generally that the direction of interest is the direction of the voice trigger, okay? So then we say, okay, then we know the direction. In most cases, this is the case, because when it's like speaking to a person, you are not running while giving some command or even giving some requests to a network recognizer. You are not running around the device. in case this is the case, what you have to do, you have to actually either to run the same number of recognizers locally, or to send multiple streams to the network recognizer. We have no other choice. So it depends already. Again, this is on the product definition. So from our point of view, there is no problem. It's the decision of the device manufacturer if it wants to support this specific scenario or not.
Thank you very much.
Thank you.